Hello everyone, this is our group and today we are going to calculate a simple number of a simple supported beam right behind us here. My name is Pure Dengarok and I'm absence number 6.
My name is Tava Badamulana, absence 8.
And my name is Naili Mustikandar Arominingsi, absent 17.
Everyone, so it's been Pure Dengarok. At this point I'm going to calculate the reactions at point A and point B. As for my friends will calculate the shear force and the moment of these supposed supported beam. Uh, we are going to first analyze the diagram. When we analyze the diagram has 2 points. We have at point A and at point B. So at point B, there is a supported machine. So we have force 1, which is point C, given as 400 kilograms. We have UDL, which is the uniformly distributed load, as 1,000 kilogram. The 1,000 kilogram it's also having a distance of 4 meters. We have force 2, which is at point D, and it has 500 kilograms. We also have force 3 at point E, which has 600 kilograms. So we are going to start by calculating the reactions at point A and point B. So let's start calculating the reactions. So when you're calculating reactions, always the summation of moment at any point, either point A or B, is equals to 0. So at this point, I'm going to base at point B, I mean. So the summation of moment, which is the sigma MB, is equals to 0. The summation of moment at point B is equals to 0. So I'm based at point B, meaning I'm going to calculate the reaction at point A. So when you look at point A is moving towards the right, meaning it's moving the clockwise moment. So if it's moving the clockwise moment, is going to be positive. So I will say at A times the total distance on the point load. So the total distance here is 8 meters, so I was multiplied by 8. But remember, I'm based at point B. But point B is moving anti-clockwise, meaning I'm going to subtract every load times the distance from this diagram here. So I'm at A times 8 minus at point E, which is force 3, and force 3 is 600 kilograms. So it's 600 times the distance, which is 1. So I multiply by 1 here. And then I go to the next force, which is force D, and it's force 2, and it's given as 500. So I minus 500 times the distance, which is from here up to here is 1.5. 1.5 meters minus minus now the UDL. So generally we have the UDL load. So for us to solve this, we have to convert the UDL to a point load. So when you are converting the UDL to a point load, you get the force of the UDL force times its actual distance, which is 4 meters. So when you multiply this UDL, you have minus 1,000 times the distance, which is 4. But remember, this UDL is always based in the center. So if it's based in the center, that means the distance from here up to here is 4 meters. So when you divide 4 by 2, you have 2 meters here, and you also have 2 meters there. So since we are calculating the UDL load, which we have converted to a point load, now it is here in the center. We are going to find which is 1,000 times 4. Then time is the distance itself. So the distance from point B is 1 plus 1, which is 2, plus 2, which is 4. So you multiply here by 4. Then you continue minus force 1, which is at point C, and force 1 at point C is given as 400. So you say minus 400 time is the distance from B to C, and the distance from B to C is 7. So we multiply by 7, which is equals to 0. So at this point here, we are going to simplify our equation by multiplying and subtracting all the values there. So I will have A times 8 is 8RA, 8RA, then minus 600 times 1 is 600, then minus 500 times 1.5 is 750, minus 1000 times 4 is 4000, 4000 times 4 is 16,000. 16,000 minus 400 times 7, we get 2,800, which is equals to 0. From this point, we are going to collect the like terms together. When you're collecting the like terms together, that means we have 8RA. Then you collect the values, the coefficient values, you collect them together. So you have negative 600 minus 750 minus 16,000 minus 2,800 is minus 20,150, which is equals to 0. We continue from here. Since we are looking for the value of RA, we are going to make RA the subject of the formula. And for us to make RA the subject of the formula, we have to move this value to the other side of the equation. But remember, this value is a negative number. So when a negative number crosses the equal sign, it becomes a positive number. So we have 8RA is equals to 20,150.
Which is equals to 4,443.926 kg times meter. This is the MS. And let me draw the moment for you. This is MA, which is 0, and then 800 right here. This MQ, and no, this MC, and then right here is MQ, which is right here, and then MD right here, MD right over here, and then ME, MQ, MD, we're going to draw it like this. Wait. This is going this way, and then going up, because ME is equals to MB. This is equals to 0. This is MB. This then is the correct calculations. Then we draw it like this. Because it is on the bottom line, it's going to be plus. Thank you.
Okay, my name is Lucy Colorado Meningsi. So here we're going to find hasil dari poin D atau disebut Z force. Pertama kita akan mencari nilai dari Z force A, yakni 2,518.75. This is from RA. And next we're gonna find point C. In point C, we're gonna choose 2,518.75. minus 400 and 2118.75. And next we're gonna find point Q. As a result, 2118.75 minus 5000. As a result, minus 1881.25. Next, we're gonna find point T, first T. As a result, minus 1881.25 minus first two is 500. Minus 500. As a result, minus 2381.25. Next, point E or C is minus 2980. I'm sorry. 2381.25 minus first three is 2381.25 minus 600. Result minus
9 2981
minus
900
981.25 and plus this point B. Point B is first B minus RP in here, so minus 2981 0.25 minus 2981.25. I'm sorry, it's plus. As a result, it's 0. So I'm gonna draw in the scale. first is 2,000 here.